Hello YouTubes, welcome back to Workshop Wasteland. Coming at you today with a new video. My wife got me a PM Research Dynamo kit for my birthday. The part number is DYN-1, and the dynamo is really just a DC motor, but if you spin it with something else, it becomes a generator. So the plans for this say that it is 10 volts DC at 10 watts or 2.4 amps, max no load voltage of 12 volts DC. So I think we're going to build this and then probably connect it to a small LED light or something along those lines. That's kind of a breakdown overview of what it's going to look like when it's all said and done. Really nice kit. Let me get you in for a little bit of a close-up here so you can kind of see what all these things look like and see how awesome these castings are. They're actually really clean. So first and foremost, we have a rotor here. This is pre-wound, typical DC motor rotor. That's pretty cool that it's pre-wound because that'd probably be a big pain in the butt. The magnets that will go inside of the mainframe to create the magnetic field. These two end caps are aluminum. Looks like you got to drill 4 holes and machine this surface to fit into the mainframe or the foot of the unit. And then of course drill or ream 2 holes for the bearings. And then this is the cast iron base or foot assembly. It's a really clean casting. Off video, I'm going to clean up this flashing, I guess it would be called, from whenever they sand casted this, but I've seen some other casting kits before and they don't look nearly this good, so that's pretty awesome that they sent you something to start out with that's really good. And then this is the bag of bits and bobs. Looks like 2 bronze bushings, chunk of aluminum to make the pulley. This brass round bar is to make the eyelet, some brushes and some screws, and yeah, looks like a pretty fun kit. So I'm going to start with this base. Like I said, clean this up off camera. I'm going to go get it mounted in my milling machine, and I'll show you where we go from there. Stay tuned. Over here at the mill, I got some emery paper in between my jaws and this cast iron part because the scale that's on cast iron is really hard and it can mess up your jaws. So that's a little trick that I learned here on YouTube, actually, I think from Blondie Hacks. Throw a piece of emery paper in between your jaws to save it. So I got this basically dialed in. It's about as good as it's going to get considering this is a rough casting, and really nothing's dimensionally square or accurate at this point. So do your best to get this dialed in as flat as you can. There are some specs in the plans for minimums. However, I think as long as you take as little off of this as you have to, and you start out reasonably square, you're probably going to be in good shape. So I'll run my indicator across this. Keep in mind that it's a rough casting, so you're going to see the needle going all over the place, and realistically all you can do is kind of get an average of it all. So I'll get you in shot here for the indicator, hopefully. So it's obviously high in the middle, you can see that with your eyes. We started at 0, and right before we drop off the edge, we're at about 4 thou, so drop off to 0. I think that's about as good as I can get it. Not saying it's perfect, but 4 thou feels pretty good to me. So run you back down here. As you can see, we come back to 0 right as we drop off the edge. So hopefully, visually appealing wise, this is going to work out, but let me swap out the tool and we'll take a cut on this. Touched off on the end. This is a 20 millimeter carbide end mill. Probably run this about 1,000 RPM, see how that cuts. All right, it's leaving a really nice finish. Didn't quite clean up on this far corner. Yeah, not quite cleaned up on that far corner. I'm going to run this back and forth, and I'll bring you back for the final pass. Ready for the next operation here, which is going to be cutting off both of these ends to give us the dimension that we need, which is 1.560. So I found the center based off of what we're already starting with, marked the center punched that, and then from the center I went 780 both directions, which will give us the 1.560. So I'll go get this thrown in the mill and show you the setup. So the two sides will be parallel to each other, and then the hole will be bored parallel in the center. So this should work just fine. I'm going to cut down to the line, and then I'll probably take a cleanup pass off the other side, pull it out, and measure it and see how that looks. Alright, so just like before, we'll come down and touch off, and then probably take about a 15 thou, maybe 20 thou depth of cut, running right around 1200 RPMs. So here we go. Little nub centered up between the two sides, but I'll bring you back whenever we get this flipped around. All right, we got that side machine down to the line. Surface finish is beautiful, and I didn't mention it earlier, but you don't need any cutting fluid whenever you're cutting cast iron because it's got a lot of graphite and carbon in it. So no cutting fluid required, and it usually turns super easy. Leaves a really nice finish. So let me get this flipped around and show you the next step. So here's the setup for the next step. I got a parallel underneath, tapped this in. I just took a 10 thou cut off that, enough to clean it up, and I'm measuring it with a depth mic. And we have about 100 thou to go, which makes sense. You can see my scribe line here. We got to cut to that scribe line more or less, but the important part is now we need 1.560. So I'll take a couple cuts and bring you back for the final. So you have to basically reprogram your mind to read a depth mic because you're pushing down into the part. So right there is 1.560, and it's confusing in my opinion to use a depth mic until you kind of make your mind think the way that it works. So especially if you're using this versus like a lathe operation, as we would turn tighter, right, it would get smaller, but in this case it's getting bigger or longer really. So we're really at 1.57576, something like that. So we got to take 15 thou off, right? Yeah. So let's do a 15 thou finishing cut, and then hopefully we're good to go. All right, 15 thou finishing cut. Take our time and make it nice. Remember, we're not really in any hurry here. I'm not getting paid to make this. And, you know, if it takes longer, it takes longer. But if you take your time and do it right, then you don't have to do it again. Or in this case, buy a whole nother kit. So 15 thou finishing pass. Alright, I'm going to take one final measurement and then I'll pull the part out and we'll see how we did. So I almost made kind of a mistake. Wouldn't have been the end of the world. But my next operation here is to bore out this hole. Now you could definitely do this on the lathe, but I'm choosing to do it in the milling machine because I think I can get a more accurate hole based off of this reference surface than using a forge awl to clamp it. So the mistake I almost made was pulling this part out. I really want this to be as square as I can, the bore being as square to this face as I can. So I got my boring bar set pretty close here by eye. This doesn't have to be absolutely perfect. You know, you can't really dial it in because it's a rough casting in there and your needle would be all over the place. But with my boring bar in here, I have it to be looking pretty good. Um, Again, probably not absolutely perfect, but it's just for aesthetics more than anything. There's extra material for our bell ends to fit in either direction. So, you know, if it shifts one way or the other a few thousandths, it's not going to matter too much. So I'm going to take a cut here with the boring bar, a nice light cut, and maybe just go in, I don't know, 50 thou or so and see how visually it looks after that, right? So we'll retract the tool back out and we'll see how it looks. I'm going to lock down my table in the X and the Y direction so it can't move on us, and then we're going to take a cut. Got the table locked down. Let's just take a little cut here, see how this looks. So I'm probably going to have to put an edge on this. These boring tools, this is just a cheapo uh, Amazon boring bar, and honestly, the edge that comes on them absolutely sucks. So let me go put an edge on this, and I'll be back. We'll see what we can do again. I really have this ring all the way around to this side, but as you can see, I don't have anything over here. So what I'm going to do is move my x-axis over that way, probably about 10 thousandths, and I'm going to call that good. I'm going to take several cuts. It's really loud, making a lot of screeching, mostly because this machine doesn't really have the rigidity that it needs. But I think once I get through this hard fire scale that's on there, it'll work better. So let me take a bunch of cuts here, get us closer to final dimension, and I'll bring you back to show you what that looks like on a full cut. So we're at 1.1 right now. We need to go to 1.33 inches. And surface finish isn't terrible. It looks worse than it feels. But like I said, this machine, this is just a, you know, one of these benchtop mini mills. So there's a lot of chatter and a lot of vibration. Only able to spin that boring bar about 500 RPMs, which is probably not ideal, but it's given an acceptable finish. So I'll bring you back for the last cut, but just wanted to give you a bit of an update. It's going pretty good. This process is just, well, boring. So I lost the audio for this clip. As you can see, what I'm explaining here is I moved the boring bar on my tool holder from the center position to the outer position, and as you can see, it put the boring bar more in line with the spindle, so there's not so much of an offset, and it significantly reduced chatter and really made the cut a whole lot better. Kind of wish I had thought about this to begin with. I'm not really sure why I didn't, but obviously keeping things more in line will always reduce vibration and chatter in your cut. And as you can see, the surface finish is still not remarkable, but keep in mind this is just a you know, like 100 pounds. It's a benchtop mini mill, which by no means is, you know, a solid Bridgeport or whatever the case might be. So I've been pretty lucky so far. I've been able to make do with what I have, and have turned out some really, at least functional parts. They might not be the most beautiful thing in the whole wide world, but they're always at least functional, and to me that's really kind of all that matters. I believe this was the final cut here on this part, taking us up to our 7/8 inch internal diameter. Looks like I'm coming in here to do a final dimension check. We were aiming for 1 inch, 332 thousandths. And if I remember correctly, we basically nailed that dimension spot on. Alright, 1 inch, 131 and a half. So pretty darn good, and there was no taper in this part, which was also great. Gonna do a quick little check with one of the magnets here, and they slid in perfectly, fit nice out at the edges like they're supposed to. So I believe we nailed the dimension. Alright, get you in here real quick, take a look and see how good we did with setting this up pretty square. So we got to find the bottom, or the the bottom of the circle. Looks like about 2 thou plus there. This is a half thou indicator, so keep that in mind. And then pretty much dead on 0 on that side. So that's pretty good. 2 thou from side to side. The only thing that would matter visually, if it were way off, you would notice it. But also it needs to be relatively straight so that a belt would run correctly on the pulley that we're going to make for this. So 2 thou is good enough. I'll take that. Alright, I think we'll end the video there. This is basically a completed project. We got to poke a hole in the top and then drill our 4 mounting screw holes, which both will be really easy. And then in the next video we'll finish it up with these 2 end bells and get them all squared away the way we need to, which will be primarily a lathe project. So if you like what you're seeing, please don't forget, like, comment, and subscribe. It would really help out. And if you're interested in the part 2 of this and the completed project, don't forget to ring the bell so you get a notification. Otherwise, till the next time, have a great night.